Hello everyone, my name is Ivy, and today I'm going to be talking about my analytical forecasting of energy consumption patterns. My analysis will be based on the examination of the current and the future landscape of natural gas consumption in the US, and also to understand the forecasting methods that can guide us towards sustainable energy management. The goal is to construct, make use of forecasting models that will help us predict natural gas usage and integrate economic factors, um, helping stakeholders make informed decisions for future infrastructure and policy development. We'll be using models such as ETS and Holt-Winters to capture trends and seasonalities, and VAR to analyze consumption with economic indicators such as transportation indexes and um, vehicle miles traveled for informed resource planning. These insights should provide um, actions for stakeholders to make informed decisions for energy production, infrastructure development, and also meeting environmental targets. Um, Data set is gotten from the Federal Reserve economic data. The data sets I will be using, or I used, are the natural gas consumption, the consumer price index for transportation, and vehicle miles traveled over time. Natural gas, as we know, is a critical energy source. It stands at crossroads of energy security and environmental responsibility. Its rising consumption driven by advancements like fracking and its role as a bridge fuel underpins the need for accurate forecasting. There's been a shift towards cleaner energy sources since the early 2000s, and there has been an increased supply, particularly in the US, making natural gas a cost-effective substitute for coal. The future role of energy policies is to balance environmental goals and also meet economic and energy needs, security needs. The first model we incorporated is the ETS model, and this model is used to predict future values by analyzing past trends, level and seasonal patterns in data. The statistical tests indicate that there might be unrecognized patterns in residual, potentially affecting forecasting accuracy. Or it also shows from the graph that there will be a steady increments growth over the next 2 years, and and the model suggests that there will be a growth over the next 2 years, and the shaded area represents the prediction intervals that expand with time, indicating growing uncertainty in long-term forecast. The next model we used is the Holt-Winters model. It's basically an enhanced ETS model, which effectively captures seasonality in forecasting data with distinct seasonal trend. The historical fit accuracy is high, showing a close match between model fitted values and actual natural gas consumption. This also projected an increase over the next 24 months, mirroring the seasonal patterns over time. The forecast suggests that natural gas consumption will follow historical trends, incorporating past trends, direction, and seasonal variation. The third and the last model incorporated is the VAR model, which is a vector autoregression model. It's a model that is ideal for interdependent variables for time series analysis. The model's interconnectivity gives us insight into how natural gas consumption correlates with economic indicators, offering a multidimensional view of the economic view of the energy sector. The math behind the model we can't see works like a hidden hand guiding these trends. And this is because there is not much random error left over. It seems the model is capturing everything it needs without missing anything. In short, the VAR method acts like a magic ball that helps us peek into what happens next with our energy and driving, giving us a trustworthy information to make plans with. The correlation matrix for the VAR demonstrates model demonstrates a strong fit with low error correlation and a robust AIC. AIC is a model fit used when evaluating a model. The independence of gas consumption error suggests accurate model specification. There is a mild positive correlation between CIP transportation and vehicle miles traveled, which hints a minimal co-movement in forecasting errors. Overall, there is low residual correlation across variables, indicating unbiased, reliable, and irreliable forecast. In conclusion, our models anticipate a consistent rise in natural gas use. This reinforces that it's an important role in transitioning towards this reinforces its important role in transitioning towards cleaner energy sources, and underscores the critical need for infrastructure growth or development and policy innovation. And with this, we recommend aligning infrastructure plans with our forecast, preparing a market volatility, and committing to renewable integration and frequent model updates to ensure that our energy system is resilient, responsive, and sustainable. Thank you for listening.